Hey everybody, today we're going to do multiplying matrices and that's it, right? This determinant thing we're not going to do. I'm going to break this up. I'm going to do this one lesson over the course of the whole week. Again, with the intention that if you haven't done the sequences and series stuff, that I'm going to keep this week, just like last week, a little bit shorter, just so that for people who haven't seen that or haven't done those things, you have the opportunity to go back and do the sequences and series. I don't care if it's late or anything like that. I do want you to try and get it. And I think it's all, but I think like 15 out of the 22 of you, or 16 out of 22 have done it. So, um, it's a short week for most of you guys, which is good. For the other ones, if you could just make sure you try and get some of that sequences and series stuff done, I think that's great. And this week is short on purpose to hopefully give you guys time. Obviously, if you're feeling overwhelmed, then, don't worry about it too much. As we're still trying to figure out how the grading is going to even work for the term or semester or whatnot. But we're going to multiply matrices together today, which is going to be a little bit different. I think before what it kind of had meant was, if we have like a coefficient here and we have, 2, 4, 6, 8, that's not multiplying matrices together. This is multiplying one matrix by a coefficient, right? And we did that in the last lesson. So that's a little bit different. That's not what we're talking about. We're actually talking about multiplying a matrix times another matrix, right? Which is something that's totally new. And most of the time you can't do it, right? You can only do it if the number of columns in A, right? So the number of columns in the first matrix is the exact same thing as the number of rows in the second matrix, right? And that's the only way you can do it. If that doesn't happen, right? If the number of columns in the first one does not match the number of rows in the second one, that's what we call undefined. And we kind of use that word a lot in math, but it works here as well. So you wouldn't have to do the problem. You just say that it's undefined, right? The operation of multiplying is undefined because you can't do it, right? Now, when you multiply it out, right, I'm going to show you how to multiply it out, but just as like a heads up, the result is going to be the same thing as the number of rows in the first one times the number of columns in the second one. That's going to be the new dimensions of the product matrix, right? So you're going to get one matrix, which will be the product, and that's it. Just keep in mind, A times B, it's the number of columns in this one times the number of, the columns in this one has to match the number of rows here. So B times A, right, it may not work, right? A times B is not the same thing as B times A with matrices. It's like the only time multiplication is not, it doesn't, it does matter the order when you're doing matrices, unlike when you're just doing regular numbers. So here we go, right? I used to just give kids a slide and make them kind of figure it out, but for the sake of time, we'll just kind of go through it. So let's say we have a 2 by 2 matrix here and a 2 by 2 matrix here, which is great because the number of columns in A is the same thing as the number of rows in B. So we can do this. Anytime you have two square matrices that are the same dimensions, it's obviously going to work because the number of columns will always equal the number of rows. So here we have like A times, what we see here is we're always going to multiply the rows by the columns, right? And that's always going to happen. So we're going to take the row of the first one, multiply it by the column of the second one. And what we're going to do is we're going to add, right? So we're going to take A and E, right? The first number in the first row and the first number in the first column. We're going to multiply those two things together and we're going to add it to the second number of the first row and the second number of the first column. So what we have here is A times E plus B times G. Whatever you get as a number there is going to be what goes in your final matrix, right, in the top left-hand box, right? Because our final is going to be 4 by 4, right? Because the number of, we just talked about that in the last slide. So then what we're going to do is like, so for, this number, however you want to do it, doesn't matter what order, right? So the bottom left-hand one, right, now I'm looking, so bottom row, I'm going to go to the bottom row of the first one, and it's the left column, so I'm going to stay in the left column here. So it's going to be C times E plus D times G, and that's going to be here, right? The upper right, okay. So I'm still in the upper row, so I'm going to take the upper row here, but I'm on the right column, so I'm going to take the right column this time. So now I'm going to multiply A times F plus B times H, and that's going to give me my upper right. My lower right is going to be in the lower row, and it's going to be in the right column. So this is where I do C times F plus D times H, and whatever I get for an answer there is going to be here, right? So let's do a practice if that seems confusing, right? So first of all, I ask myself, can I do A times B? Yes, because the number of rows, right, here and here matches the number, the number of columns here matches the number of rows here, right? So you're good. So what I'm going to do, I'm going to set up my box before I start, and I know that I'm going to have a 2 by 2 matrix, right? Just like this one was. So I'm going to take my first row, and I'm going to take my first column. So top row, left column, top left. That's going to be the number right here. So I'm going to do 1 times 5, which is 5, plus, now the second number is 4 times 9, which is going to be 36. Right? And then for my final answer, right, so I'm just going to do that out. I know that that's going to be 41. Now, next what I'm going to do is, let's say I want to do the top right next. So I'm still on the top row, but now I'm going to use the right column. So I'm going to do 1 times negative 7, which is going to be negative 7. And then 4, second number, 4 times 6, which is 24. And that's going to be negative 7 plus 24. I know that that's going to be 17, right? So that's going to go, just going to fill out the rest of the matrix here. And that's it. Okay. Now with the bottom left, I'm going to take the bottom row, and I'm going to multiply it by the left column. So 3 times 5 is 15, right? 3 times 5 is 15. So I'm going to say 15. And then the second number in the row, second number of the column, negative 2 times 9 is going to be negative 18. So I'm just going to put minus 18. 15 minus 18. Oh, I put that in the wrong spot. Sorry. All right, so here we go. I got 15 minus 18, and that's going to give me negative 3. And then last but not least, I'm going to do bottom right. So bottom row, right column. I have 3 times negative 7, which is negative 21. And second number, negative 2 times 6, which is minus 12. So I'm going to get negative 33. Right? And that's pretty much it. So I think you have just a few questions to do for the work on this one. And that's it. Again, it doesn't have to be square, though, as long as the number of columns here matches the number of rows there, then you are okay.